Welcome to an ultra-scale PCI Express quick take video. In the video today we're going to look at how to create a tandem design for the Xilinx ultra-scale architecture. Now if you need a refresher on what exactly tandem is, take a look at the Xilinx quick take video called Tandem Configuration for 7 Series, and that has a lot of details of exactly what the tandem solution entails. If you just need a really quick refresher, this is the methodology where we load the PCI Express part of the bitstream first, such that it can be seen during enumeration, and then the rest of the bitstream loads in the background. So in the video, what we're going to do is we're going to start off by creating a design, and we'll walk through how to create that design. Once we have that design created, we'll go ahead and load it onto a Xilinx KCU105 board and ensure that it comes up with the link width and speed that we want. And then the last thing that we're going to do is we will go ahead and download that design using the Xilinx provided drivers. We'll show you how to install those drivers and actually download that second stage bitstream over the PCI Express link. Alright, so let's go ahead and get started. So the first thing I like to do whenever I do a project like this is go ahead and create a new project. And we can do that here in the Vivado. And I'll go ahead and put it in the location that I want on my drive. And I can leave everything else as default. And here we want to make sure to select the KCU105. Now once we're here, we're going to go ahead and open up our PCI Express IP block such that we can customize it. Now we have a very nice customization GUI for the ultra-scale PCI Express IP core. And to get to tandem, notice that we need to go to the advanced mode, and that's going to give us a lot more options. In this case, we're going to go ahead and make it by 8 Gen 3, and we do need to make sure to select the KCU105 development board within the GUI. Now there's 4 different options here for tandem. The one that we're going to do is just the tandem solution, and what that does is that allows us to download a first stage and then a second stage, and that's it. Now field updates in the future, and that will allow us to download multiple different images over the PCI Express link without bringing PCI Express down, but we're going to skip on that for now. We'll talk about that in a later video. We're not going to make any other changes for this particular example, so go ahead and generate it. We don't need to synthesize it at this point because we will in our example design. Alright, once we have that created, go ahead and click on that XCI file, right click on it, and then we want to open up the IP example design. Now this IP example design is going to have all of the things we need to create a very simple design, and it's going to open up in a new Vivado window. So we can close the one we have in this new one and just load up the new one. So here you see we have this simple example design, and what we're going to do is we're going to add an output to it. And this particular output that we add is going to be in the same bank as the system reset. And that system reset input has to be turned on. So when we do PCI Express, that entire bank gets turned on. So all of those IOs are going to become active right away. And so there's some things that we need to do to take care of that and make sure that that IO is in there correctly. So what we're doing right now is we're just adding the design here. Notice we do have to instantiate the OBUF in the top level of the design. And we'll see that is in a minute. So once we have that, there's 2 XDC files here. We're going to go ahead and go to the first one that contains our location constraints. And I've already looked these up, and we will go ahead and put in the package pin and the IO standard that goes along with where we're putting LED 1. Also note here that there are a bunch of settings for if we have a SPI device, and a SPI device is what we have on this particular board. So it's actually a SPI by 4, so we need to update that. But all of these settings are needed to make sure that that bitstream gets generated correctly when we do a SPI device. Okay, now we have that done. Let's go ahead into the tandem side of the XDC files. First thing we want to do, because we're doing tandem PCI Express, we need to uncomment these 2 things. If we don't do that, we end up with the Tandem PROM type bitstream where both the first stage and second stage are saved on the PROM. But because we uncomment those, now what that's going to do is give us what we call a Tandem PCIe type bitstream where the first stage is on the PROM, the second stage resides in the PCI Express space. All right, so then the next thing we want to do is we want to go down and we're going to put in our filter to add that OBuff to the P block. And we also need to set the hd.tandem property on it. And that's all we need to do to add that to the Tandem first stage. We also, in the bitstream settings, need to turn on the bin file so we have that bin file ready to go when we want to load it over PCI Express. Okay, we go ahead and click save on everything and we will generate the bitstream. We're going to speed that up here so we don't have to sit through it. Once it's done, we can take a look at the implemented design, and what we'll do is we'll look at the device view where these different locations are of some of the different key components. And you'll see this purple block right in the middle there, and that is where the IOB block is. And so you see LED 0 does not sit in that IOB, so that LED is actually going to be unconfigured to start. But then reset and LED 1 both sit in that bank 65. Those will both be configured, and so they, especially the outputs, they may glitch. Now if you look at the product guide for PCI Express, you can find information on how to make it so that those outputs don't glitch if that's a concern. Since it's an LED, we don't really care. Alright, so the next thing to do is we need to change to the directory where we have our bitstream. And once we get there, we are going to write the PROM file or write the MCS file. So the XDC file has an example. You can also look this up in the different user guides and product guides that are available. We'll go ahead and copy in the name of that bitstream and with the correct settings and hit enter, and now that creates the MCS file that we need to load into that SPI flash device that we'll use for initial configuration. We also see that we've got our bin devices here, and we'll be copying those over, at least the stage 2 bin. We get both of them. We only need Tandem 2. Alright, so there's our KCU105 board. You can see it there in the inset. That's what it looks like when it's plugged into our system. We're going to go ahead and right click on this, and we're going to add a configuration device. And in this case, we've looked it up. We know it's this N25Q256 1.8 volt, and we'll add our MCS file that we generated for it. And once we get that selected, we will program that into the we'll program that into the flash. So now when that device boots up, it will boot up using only what is needed to bring up PCI Express. And there's a picture of what it's going to look like. Both LEDs are inactive. Done pin is high. And when I say inactive, one is configured and one isn't. And that's why we had them both there in static states. Okay, so if you look at Xilinx answer record 64761, this is where we keep drivers and an example application that show how to load the bitstream over a PCI Express link. And we have drivers for both Windows and Linux. So the first thing we have to do in Linux is download this PCIe utils directory from the link that's given and compile it for our system. And then we've also downloaded the Xilinx files that you can find at that Xilinx answer record. And we change into the Linux directory, and the next thing we need to do is we need to compile those drivers so that we can use them to download that PCI Express bitstream. Now, one thing you might find when you do this is if you get an error that says it cannot find -LZ, what I found is that needs the zlib development environment to be installed. And you can get that just as you see here using yum if you're set up to do that. Alright, so once we've done that, we'll go ahead and rerun our compile command, and now our driver is compiled. And we have an application called mcap, and we can use that application just by doing /mcap, and -h will give us a list of different settings that we have available. Notice though that we do have to specify the device ID, and that is the device ID that we gave this particular PCI Express block during the initial configuration of the IP back in Vivado. So I've already copied over the bin file, the Tandem 2 bin file, and when I specify that, it will go ahead and load the bin file over PCI Express, and you'll see done blink, and then our LEDs become active. So one of them is a heartbeat, and then the other one is a status signal, and we expect it to be 1. And once we've done that, we can still see that our PCI Express device is up and available and ready to be used with whatever application that we've loaded. So that concludes how to do a Tandem PCI Express in UltraScale. Hopefully you find this useful, and feel free to leave us any feedback and we'll answer questions as they come in. Thanks a lot.